In this chapter, we're going to start talking about sequences and series. So specifically in these notes, we see that we are doing sequences today. So a sequence is essentially a list of numbers that have some kind of relation to each other. So this right here, example 1, says we have a of n, a formula, equal to n squared. We're only concerned with n between 1 and 8. So that means I need to find a of 1, so 1 squared, which is 1. That's the first number in my sequence. Then I do a of 2. Well, that's 2 squared, so that's 4. 4 is the second number in my sequence. A of 3, you get 3 squared. Again, we get 9, so 9. Well, at this point, you could probably figure out where the sequence is going. You got the perfect squares. So 1, 4, 9, 16, 25, 36, 49, and 64. So I'm going to just do a little bit more work here. A equals 4 squared, which is 16, equals 5 squared, 25. A to the 6th equals 6 squared, which is 36, and so on. We realize that we have the perfect squares. Alright, so now our next pattern, we have c of n equals negative 2, the quantity, raised to the n minus 1. So c of 1 equals negative 2 raised to 1 minus 1. So that's negative 2 to the 0 power, which we know anything to the 0 power is 1. So we got 1. C of 2 gives us negative 2 raised to the 2 minus 1, which is negative 2 raised to the first power, which is just negative 2. Alright, then we've got C3, negative 2 raised to the 3 minus 1, negative 2 squared, which is going to end up being positive 4. C of 4, we've got negative 2 raised to the 4 minus 1, negative 2 raised to the third power, we get negative 8. And then finally C5, negative 2 raised to the 5 minus 1 is negative 2 raised to the fourth power, and we've got positive 16. So notice that this sequence is an alternating sequence. So alternating, that's something that we'll talk about when we come up with these. Now, this seems like a lot of work to be doing, doesn't it? So before I go to the next example, I'm going to actually go ahead and say flip to the next page on your notes, and look, I gave you a way to do this in your calculator. Yes, you can generate all these terms for you using your calculator, because sequence and series are a big thing in computer applications. So of course something like the graphing calculator will be able to do this. So I'm gonna go ahead and I'm gonna actually try to show both of these at the same time. So we've got our sequence here. To get there, we need our calculator. We need to follow, so second, catalog, that's on the 0 button. So down here at 0, catalog, and then I get a list of things. You're going to press the LN button so that you get down the list to the S's. Arrow down so that we get sequence. That's what we want with the parentheses. Press enter, and now we're going to follow type the expression or formula we used. We used n squared. Well, there's no n on our key, so we're going to use x squared. And then I need a comma, because I have my sequence. I'm going to use x, telling it to evaluate at x, comma, and type the starting domain number. So we started at 1, comma, the ending domain number. So the ending one, we ended at 8, and then we need a parentheses and enter. And look at that. It listed them there for me. All I had to do was type this in my calculator. So let me show you here. We had sequence of x squared, comma, x, domain start, domain end. And then that gave us our list of values. So let's do the same exact thing for the last two problems. Or let's do the same thing, make sure it works still for C2. So I'm going to go to second catalog. I'm going to hit the LN button to get down to sequence. And now my formula is -2, so -2 parentheses to the x minus 1, since I don't have n. I'm using the variable x. I'm starting at 1, and I am ending at 5. 1, -2, 4, -8, 16. Matches the sequence I had. So again, I did sequence of -2 raised to the x minus 1, used x, started at 1, ended at 5. Alright, for these remaining two, I'd like you to show the first few at least, and then check with your calculator. So you should show some work for these, and then check with your calculator. So these ones you are trying on your own. Alright, so now let's talk about coming up with the sequence. We are going to work backwards. So we got to think a little bit about these. If I'm starting with 1, then I got to think of how I'm moving. Well, I'm moving up by 2, again up by 2, up by 2, up by 2. So I realize that there's this constant of 2 going on. So constant increase of 2. Well, what do I need to start at here? Well, I gotta start at 1. So I gotta think about how I start at 1 and then increase by 2. Well, if a of n, so I need a formula, an equals something times n to get me to 1. If I'm increasing by 2, I'm probably going to multiply by 2. But if I need to get 1, if I put 1 in, I need a1 equals 2 times 1. Well, that's 2. But I want 1, so maybe I need to subtract 1. Well, let's try that with a2. Let's try 2 times 2. Well, that's 4. If I subtract 1, I get to 3. So then it looks like my formula is starting to become an equals 2n minus 1. Well, let's check one more. a3 equals 2 times 3 minus 1. 6 minus 1 is 5. So I got there. You should also notice that this is how you would get odds in your formula. Alright, so that's the formula here. Again, you just kind of have to play around with it and see what you multiply by to get there. Another thing here is it says there is more than one correct formula. So if you can come up with a different way of doing these, by all means, go ahead. So the first thing you should notice about example 6 is alternating signs. So alternating signs there, well, that means that we're going to have to use a power, basically. So alternating signs, we need a negative base, and since the first term is positive, so first term positive, that would mean we need an even power to start with. So even power. So it can't be n equals 1. It needs to be n minus 1. So first term positive, we need to use n minus 1 as our power. So let's start a formula here. a1 needs to equal 1. Well, I need negative 1. And then I need to try n minus 1. So a1, well, that's going to be a 1 here, which equals negative 1 to the 0 power, which is positive 1. So that checks out. Now let's try A2. So -1, 2 minus 1. It's -1 to the first power, -1. Well, that checks out too. Let's try another one. -1 to the 3 minus 1, which is -1 to the second power, which is going to be +1. Alright, looks like we're alternating here, so then all we need to do is just write the formula down. So an equals -1 alternating to the n minus 1 power. So if it started with a negative, we could have just used n. But since it didn't, we had to kind of think about that. Alright, example number 7, the final one. What we should realize from this formula is we start with 0, then we have 1, then we have 4, then we have 9, then we have 16. Should notice that there are perfect squares here. So perfect squares, but not starting at 1. We have that 0 first. So perfect squares makes me think I'm going to use n squared. But if I do an equals n squared, a1 is going to be 1 squared, which is 1. So that doesn't work. We need a2 to be 1. If a2 is 1, think about working backwards a little bit. We need to get 0. Well, what about n minus, instead of n squared, n minus 1 squared? So we were 1 behind. But not starting at 1, we're 1 square behind. So think minus 1. So let's try n squared, or n minus 1 squared. So a1 equals 1 minus 1 squared, which is 0 squared. That's 0. That checks out. a2 is 2 minus 1 squared, which is 1 squared, which is 1. That checks. Again, a3, 3 minus 1 squared, we get 2 squared. Well, that's 4. It checks out. So my formula here is an equals n minus 1 squared. So right now, basically what we're doing is we're kind of using our knowledge of how numbers relate to build a formula to get a sequence. These 3 ideas are something that you should kind of use as you go ahead and start the homework for this assignment. We'll actually talk about more of the pattern in it in 13.3.